Hello. Hello and welcome to this video. In this video, we will solve problem number 241 to 250, that is 25th set of polynomials and quadratic equation. But before that, I will quickly show you how to download the PDF. You go to my website, stock.org. You click this second link available in Algebra here, and it will open in a new tab, and you can download the PDF from here by clicking the save button in your browser. And don't worry about typing or going to the website. I will put this link in the description. So with that out of the way, let's head into our problems. Okay. So we have solved up to question number 240. We are going to solve 10 next problem. So as always, I'll say that when I'm stating the problem, pause the video, and only if you cannot solve the problem, you should look at the solution. So without further ado, let's get started. Question 241 says that if the equations x square plus cx plus bc is equal to 0 and x square plus bx plus ca is equal to 0 have a common root, show that a plus b plus c is equal to 0. Show that other roots are given by the equation x square plus ax plus bc is equal to 0. So we let alpha to be the common root, and then we substitute the alpha in two given equations and we cross multiply. We arrive at alpha square by ac square minus ab square is equal to alpha by ab minus ac is equal to 1 by b minus c. So from the first two conditions, we get alpha is equal to minus b plus c from this. Okay. And from the last two, we will have alpha is equal to a. Now, since both are values of alpha, we can say that a is equal to minus b plus c. So we get a plus b plus c is equal to 0. Now we let the other roots of the equations be beta and beta 1. Then alpha beta will be AB and alpha beta 1 will be CA. So we put alpha is equal to A, we get beta is equal to B and beta 1 is equal to C. Once we have that, we find the equation whose roots are beta and beta 1, and the equation would be x square minus beta plus beta 1 into x plus beta beta 1 is equal to 0. That is x square minus b plus c plus bc is equal to 0. Again, we put b plus c is equal to minus a. We get the equation as x square plus ax plus bc is equal to 0. Question 242 says that if a, b, c are in the set of real numbers and the equations ax square plus bx plus c is equal to 0 and x square plus 2x plus 9 is equal to 0 have a common root, so that a is to b is to c is equal to 1 is to 2 is to 9. So if you look at the roots of the equation x square plus 2x plus 9 is equal to 0, they would be imaginary. Why? Because discriminant is b square, that is 4, minus 4ac, that is 4 into 1 into 9, 36, that is minus 32, less than 0. So the roots would be complex, not really imaginary, complex numbers, and they will appear in pair because complex roots appear in pairs. So both roots will be common, and therefore the ratio of coefficients would be a is to b is to c is equal to 1 is to 2 is to 9. Now we have deduced the condition for common roots when we did the theory part. So from there it follows that if both roots are common, the ratio of coefficients would be same. Question 243 says that find the value of p if the equation 3x square minus 2x plus p is equal to 0 and 6x square minus 17x plus 12 is equal to 0 have a common root. So very straightforward question. We let alpha to be the common root and we substitute alpha in the given equations to obtain 3 alpha square minus 2 alpha plus p is equal to 0 and 6 alpha square minus 17 alpha plus 12 is equal to 0. We perform cross multiplication. We get this condition alpha square by minus 24 plus 17p is equal to alpha by 6p minus 36 is equal to 1 by minus 39. So from first two we get alpha is equal to 17p minus 24 by 6p minus 32, and from the last two we get alpha is equal to minus 2p minus 12 by 13, and we equate both. We get p is equal to minus 15 by 4 and minus 8 by 3. Question 244 says that show that mod x mod x square minus mod x minus 2 is equal to 0 is an equation. So there are three cases actually. Okay. So one of the cases when x is equal to 0. So minus 2 is not equal to 0. Now it is not satisfied by x is equal to 0, therefore it is an equation. So next question is 245. Show that x plus b into x plus c by b minus a into c minus a plus x plus c into x plus a divided by c minus b into a minus b plus x plus a into x plus b by a minus c by b minus c is equal to 1 is an identity. There is a spelling mistake. It should be identity. A T is missing. So we look at question 245. We put x is equal to minus a, the equation will be satisfied. So if you put x is equal to minus a, it will become b minus a, it will become c minus a, it will become 1. And this term would be 0 and this term would be 0 because x plus a would be 0. So x is equal to minus a would be satisfying this. Okay. Similarly, it would be satisfied for minus b and minus c. The highest power of x occurring is 2 and is true for 3 distinct values of x. Therefore, it cannot be an equation but an identity. Question 246 says that if a, b, c, a1, b1, c1 are rational and equations x square plus 2bx plus c is equal to 0 and a1x square plus 2b1x plus c1 is equal to 0, have one and only one root in common, prove that b square minus ac and b1 square minus a1 c1 must be perfect squares. So since both roots have only one common root, it has to be rational because irrational and complex conjugate will appear in pairs and therefore both the roots will become common. Therefore, the two equations must be rational and the discriminants must be perfect squares. So you find out the discriminant of perfect squares and the determinant would be b square minus ac and b1 square minus a1 c1. This shouldn't be c2. This should be c1. So therefore, these two terms must be perfect squares. Okay. Question 247 says that if a square minus 1 x square plus a minus 1 x plus a square minus 4a plus 3 is equal to 0, be an identity in x, then find the value of a. So what we do is we equate the coefficient of or similar powers of x. So we get coefficient of x square is equal to a square minus 1 is equal to 0. So a is equal to plus minus 1. Coefficient of x, that is a minus 1 is equal to 0, we get a is equal to 1. Constant term, we make it 0, we get a is equal to 1 and 3. So the common value of a is 1, which will make this an identity. Question 248 says that solve x plus 1 by x whole square is equal to 4 plus 3 by 2 x plus 1 by x. So in this case, the two ways you can take x plus 1 by x is equal to y and then evaluate y square is equal to 4 plus 3 by 2 into x minus 1 by x and so on you can do. But we will take the, this should be plus x. Okay. Okay, now I'm confused. Over here it's all minus x. Okay, we'll assume that this is minus x. Alright. So we have this x plus 1 by x whole square is equal to 4 plus 3 by 2 x minus 1 by x. We bring everything to one side and then we can write that x minus 1 by x whole square plus 4x into 1 by x minus 3 by 2 into x minus 1 by x minus 4 is equal to 0. Then we substitute a is equal to x minus 1 by x. So we get a square minus 3 by 2, a is equal to 0. And therefore 2a square minus 3 is equal to 0. So a is 0 or 3 by 2. If a is 0, then x is equal to plus minus 1. Otherwise, if a is 3 by 2, x would be 2 and minus 1 by 2. So you got 4 values of a. I will check this, the sign of plus. Now question 249 says that solve x plus 4 into x plus 7 into x plus 8 into x plus 11 plus 20 is equal to 0. So we have this and we multiply x plus 4 with x plus 11 and x plus 7 with x plus 8. We get x square plus 15x plus 44 and x square plus 15x plus 56. We substitute x square plus 15x is equal to a. We get a plus 44 into a plus 56 plus 20 is equal to 0. We solve this quadratic equation, we get a is equal to minus 46 and minus 54. We plug in the value of a in this equation, we get x square plus 15x plus 46 is equal to 0, and we have two irrational roots for this. And similarly for a is equal to minus 54, we get two rational roots, or rather real numbers, or integers in fact, minus 6 and minus 9. Now we come to the last problem of this set. We have solved 3 to the power 2x plus 1 plus 3 square is equal to 3 to the power x plus 3 plus 3 to the power x. So in this equation, we plug in 3 to the power x is equal to a. So this becomes 3a square plus 9 is equal to 28a. And therefore a is equal to 1 by 3 or 9. So if a is 1 by 3, then x is minus 1, and if a is 9, then x is equal to 2. So with this, we come to the end of 25th set of problems on quadratic equations and polynomials. I hope that you are enjoying this series and finding it useful and informative. If you have not subscribed the channel, then please make sure you subscribe and like the video, press the bell icon and all that which you hear on every YouTube video. The reason is same. The reason why every YouTuber says that these things is because it takes a lot of effort. And when we see that the number of views are increasing, number of subscribers are increasing, then we find our effort to be meaningful. Otherwise, it is disappointing. Okay. So with that, thanks a lot for watching the video. I'll see you in the next video. Enjoy.